Hello and welcome to your second instructional physics class. I am Mr. Marquez, your online teacher. Now, today we're going to talk about the second chapter, which is displacement and velocity. Okay, so displacement can occur in many different ways, but we're only going to talk about linear displacement. For example, if a gecko, for example, is if you put it on a ruler and it's standing on the 3 centimeter line and then it moves all the way up to the 6 centimeter line, if we want to find out the displacement, we subtract, right? We subtract the final displacement minus the initial displacement, or the final position, excuse me, which would be 6 minus the initial position, and that would be 3. So we could say that the displacement of the gecko was 3 centimeters. Again, all I did was I talked about linear displacement, and an example of a gecko, although we can do whatever we want. I'm not going to draw a gecko, so I just did a little arrow. It was standing at the 3 centimeter line on a ruler, and then it walked up to a 6 centimeter line, and you want to find out the total displacement. How much did it move? All you do is subtract the final position, which would be this one right here, and since it's in a vertical position, we use the x. Because of the x on the number line, we say the final position minus the initial position, which would equal the displacement, which in this case is 3 centimeters. Now, one of the variables, or one of the things that affect displacement, is obviously time. And when we talk about time and we talk about displacement, we're actually talking about velocity or average speed, right? Although we're going to discuss a little bit later on that velocity is a vector and not necessarily a scalar. But for the time being, we're going to say the velocity can be defined as the change in position over the change in time, which is actually defined as the final position minus the initial position over the final time minus the initial time, or simply put, displacement over time interval. And what I'm going to do is I'm actually going to give you a very quick example on how to work with this formula. Obviously, there are other ways or other variables that we need to read when working with these exercises. And then what you're going to do is, once you've seen this video, you're going to read pages 38 through 42 of your physics book and answer problems 1 through 5 on page 42. But to kind of get to what I mean, this is what I mean. It says, during a race on level ground, Andrea runs with an average velocity of 6.02 meters per second to the east. What is Andrea's displacement after 137 seconds? Now, it's very important that we understand that we take into account the direction to the east, because we have to remember that displacement, vertical displacement, can occur horizontally or vertically. And in a number line or in a coordinate plane, we know that all the numbers that go up in y are positive, and all the numbers that go down are negative, and all the numbers to the left are negative, and all the numbers to the right are negative. Or, better put, north is positive, south is negative, east is positive, and west is negative. Now, the negative just refers to the direction, not necessarily the number itself. Now let's look at the info that we have in this problem. The information that they're giving us is her velocity, because it's saying that her velocity is 6.02 meters per second. So that we know is the average velocity, and the time interval, which is 137 seconds. So what we're looking for is the displacement or the change in x. So what we're going to do is we're simply going to plug these numbers into the variable, and we have the average, instead of saying v average equals the change in x over the change in time, we simply say 6.02, which is our average velocity, equals the change in x, which is what we're looking for, over 137 seconds. Now, very important that we understand to the east, because that's indicating that she's moving to the east, which is a positive direction. So what we're going to do is we're going to simply multiply. We're going to get rid of the 137. We're going to solve for the change in x by multiplying 137 on both sides. And we're going to do that here as well. and these two are going to cancel out. And 137 times 6.02 is 825. And we have seconds and we have meters per second, right? Because seconds is the unit of time, meters per second is the unit of velocity. Seconds cancels out with seconds, so 825 meters is our change in x, and 825 meters to the east, to be more specific. So it's really simple. Now, you're going to have some of these problems where you're going to probably have two different times or two different displacements. If that were ever the case, always remember that the xf, or the final position minus the initial position, or the final time minus the initial time. In this particular problem, we did not have the initial time or final time or the initial or change in position or anything like that. They just gave us the time without assuming or taking into account the information of where it started. So all we did was we wrote the formula: the average equals change in x over change in time. According to our problem, the average velocity, which it was 6.02 meters per second, the change in time was 137 seconds, and we have to find Andrea's displacement, which is the change in x. So we plugged in all the numbers, and to solve for the change in x, we simply multiplied 137 on both sides, and 137 and 137 cancel out, and 6.02 times 137 is 825. Our units cancel out because 137 seconds cancels out with 6.02 meters per second, so the seconds cancels out with seconds, and that leaves us with 825 meters. And this example is on page 42 of your textbook. You are going to answer problems 1 through 5 on page 42 of your textbooks. If you have any doubts or questions, you know where to find me. So stay safe, and we'll see each other soon. Bye-bye.